Hello everyone. So for this lecture, we're going to talk about predictive analytics. So we talked about in the previous meetings how there are different kinds of analytics that you can perform depending on the kinds of insights that you're looking for. And we've already tackled descriptive analytics. And for today, you can build on top of those insights and form predictive analytics as well. So we're not really going to go dive deep into predictive analytics since the expertise that you need for this one is a little bit outside the scope of this course. A lot of the skills that you need to learn for this one would be towards data scientist tasks. So we are still going to discuss it a little bit to introduce to you how you perform predictive analytics, what steps you can do, and to use orange data mining as a tool, for example, to perform predictive analytics. Okay, so beyond descriptive insights, you can also use data analytics tools in order to form predictive insights. As discussed earlier, predictive insights, it involves forming predictions based on historical data. So historical data in this context would refer to data that you already have and something that you would be interested in for a specific problem. For example, you would be interested in predicting a specific variable based on the data that you already have. So in the context of businesses, for example, let's say you have historical data on what your sales figures are in the past few months. And you might be interested in predicting what would be the sales figures in the upcoming months as well. So that's an example of predictive insights that you might want to learn, that you might want to reveal using predictive analytics. So in order to create predictive insights, you need to train a model on some historical data. And a model in this context refers to a mathematical equation or a statistical formula that takes in values from features as an input and produces predictions as an output. So for example, you have a linear regression model right here, and you're going to use this model. You're going to give it these values from these features as inputs. And if the model is working correctly, it should be able to give you an estimate predicting, for example, the exam score. Given that these are the previous score of the student, the student doesn't have a learning disability, the student studies 5 hours per week, and the student's parents' economic status is medium or moderate, for example. And based on that, the model will be able to output a prediction on what the exam score would be. So depending on the target variable being predicted, predictive models can either be regression models or classification models. So this is an example of a regression model. You can see by the name right here, linear regression model. And the type of model depends on the target variable that you're predicting. So regression models, these models predict a continuous quantitative variable. So for example, prediction, that is a quantity, that is a numerical value, this exam score right here. So this one you would need a regression model for this one. Another example in the context of business, again, the one I just mentioned, the revenue or sales, that is a qualitative value. That is a measurement, a numerical value. It describes the total profits for a given time period. So if that's the case, you would need a regression model for that one. So the opposite of a regression model would be a classification model, and classification models predict some categorical or qualitative variable. So for example, you're predicting the patient outcomes of a given patient profile. So this is in the context of healthcare. So patient outcomes could have the following variables. It could be admitted to ICU, admitted to a different station, or worst comes worst, deceased, for example. So these are the different patient outcomes that this healthcare unit will have. And if that's what you're predicting, if that is your target variable, then you're gonna need to work with a classification model. So during the predictive analytics side, of course, the majority of your effort would be towards creating this model right here. So you're going to need to create a model that is, again, trained on the data that you have, the historical data that you currently have. Training a model allows it to learn the underlying patterns and relationships between the features and the data set. And you're going to follow the following steps right here in order to train the model properly. And I'm also going to show you those steps in Orange Data Mining as well. So before you start training, you need to prepare the model first using these sub-steps right here. The first thing that you need to do is to select the features and the target variable that you're going to predict. So before you begin training, you need to select which features will be included and excluded for training. In some cases, you might also need to convert some features into quantitative values because some models are only compatible with quantitative features. So you also need to set up the correct target column as well. So you need to properly label which column or which variable are you predicting. So let's look at an example right here. I'm actually going to use the example that we're using in our midterms assessment. So I'm going to, I think I have it imported already. So let me just show you the data set right here. So to select which target, you just need to change this to the correct target column. So right now it's using the selected column that is created based on the selection I did right here in this data table widget. So I need to get rid of this feature right here, and to enter this one as a target, I need to first add it into the ignored list and then enter it into the target. So using this button right here. And if you want to ignore some columns, if you want to drop some columns, you don't want to include it during training, you don't want the model to consider those features, you can just ignore it here as well. So let's say I don't care about this feature. Let's say I don't care about, let's say, the destination station, for example. So I can ignore that. But for this specific context, I will include all of these columns, these features right here. I want the model to consider all of these features when it's trying to learn the underlying patterns within them. This one right here is already ignored. I can, meta variables will not be included during training, so I don't need to add it to the ignore list right here, but I will do so as, I'll just do it as well, since the strip ID right here is just an ID value. But actually I might need it later, so I'm gonna keep it here in meta. So that's the first step, selecting the features and the target variable. So one thing that you need to consider though is the curse of dimensionality. So curse of dimensionality is a term in machine learning and data science. It describes how models have difficulties when learning from data sets that have a lot of dimensions. Dimensions in this context, this refers to the number of features that you have. So if your data set has a lot of features, it becomes harder for your model to learn the underlying relationships within them. And that might be a reason why you would end up deciding to ignore some features, because you want to avoid this curse of dimensionality right here. But this only happens when you really have a lot of dimensions, when you have a lot of features. Let's say you have like 100 features and you're working on a simpler model, then you're gonna have a difficulty with trying to learn the underlying features from that. So it might be helpful to pre-process your data in such a way that you either ignore some columns or you combine some columns in a particular way. For the context that we have right here, we're not going to ignore some columns. We're going to keep all columns or features, and we want them to be considered in our model. So let me label these ones first. This is the dataset for training, for model building instead. The next thing we need to do is to select a model. After we select our features and the target variable, we will select the appropriate classification or regression model based on your dataset or target. So what we're working on right here is the target known as, actually I'm not going to connect it. Oops, that's wrong. This one. Logistic regression, and I'm just going to keep it there first. The next step is to split our dataset into partitions. After setting up your dataset, you will need to split the dataset into dedicated portions. Or portions or partitions. You will need to decide how to distribute the samples into the following portions. So you usually have two, but you can also have a third one, the validation portion right here. So the training portion, these are the samples used during actual model training. And you also have the testing portion. These are the samples used to test the performance of the model. And the most basic way for you to split the dataset would be just to have as much training samples as possible while keeping a small amount of testing samples for testing. So the idea why you need to split your dataset into these is because the model will be trained on this portion right here, while it will be assessed, its performance will be assessed using this portion right here. And the reason why it has to be separated is so that your model avoids cheating. You can imagine it like this. The testing portion would be the exam questions that you're going to give your model to assess whether the model is good at predicting or not. And the training portion right here would be what the model studies on, so that it's able to learn the relationships and the underlying the relationships and the patterns in your data set. So if you're going to mix these portions together, then your data set will be able to cheat, because it will be able to know in advance what the questions are. It will be able to learn based on what the exam questions are. So to avoid cheating, you would want to separate these two together. Train it only on the training portion, and then test it on the training and on the testing portion. In some more advanced cases, you might need the validation portion, and this is for the setting of the hyperparameters, for example, for tuning your model. And we're going to discuss what hyperparameters mean in the next section right here. So you need to split the data set in such a way that the model is able to train as much as possible while leaving enough samples to properly test the data set. So the more samples used for training, in almost all cases, the more samples used, the better the training is, the better model you're going to end up with. But you still want to leave enough samples to be able to properly test as well. You need to basically create a large enough exam for you to accurately test the performance of your model. So you just need to balance that. So here are some recommendations for splitting. It really just depends on you, and it really depends on the dataset that you're using. So for example, you can leave 75% for training and then the rest for testing, 90% for training and then the rest 10% for testing. So if you have a lot of samples, and then if you have a validation portion as well, so you can leave 80% for training, 10% for validation, and then 10% for testing. So let's look at an example of how this works. So there's a widget for the splitting of your train and test. You can use the data sampler widget right here. I'm going to rename this let me rename this into the training portion so that I don't mix these two up together. Sorry. not the training portion. This is the testing portion. Right there. So now that I have the training and the testing right here, I can move on to the next step. So once the dataset is fully prepared, it's now split. I have selected the model, I have selected the target variable and the features I'm going to use for training. Some models will also require hyperparameter tuning. Hyperparameters are variables that you, as a data analyst or a data scientist, will need to set. These hyperparameters will affect how the model is trained, therefore it will also affect how good the model is at predicting. So what is an example of a hyperparameter? So depending on the model that you're using, you can have different hyperparameters. So here, the logistic regression model has this hyperparameter right here called the regularization type. You can choose from these two, or you can choose neither. You can use lasso regression or ridge regression, and depending on that, you can use the C value right here from weaker to stronger. And this will basically just prevent overfitting, but we're not going to discuss deep or at all on what these hyperparameters do, because these are more data scientist skill sets as well, and it will take a long time to discuss that. You're going to have to discuss the mathematics behind how that model is being trained and how that model predicts. So this one right here is outside the scope of this class, but for the sake of experience, we can try playing around with this one. So let's say I set my regularization type to lasso, and then this strength right here into 11, which is just in the middle of weak and strong. So if you're not sure on what hyperparameters to set, Orange Data Mining usually set the default values into something appropriate. So you can just leave it as is. So this model right here will need a data to train on. So I'm going to give the training portion right here. Not the selected data, I want all of the data right here. So the red line right here means it's still working, by the way. Oh, sorry, not the red line, but the red dot that you saw a while ago. So instead of the selected data, I want the entire data set. So if you see the red dots here, it's still training. So you have to wait for this to complete. And then now it works. And that was basically step 2 done. Step 2 is model training, and this is the easiest part of the process since this one works automatically. Once you've set up everything, model training will work automatically, and depending on the chosen model and the size of the data set, model training can take a long time. So we have 1,900 samples in the training portion right here. So that's why it took a little bit longer. And after we completed the training right here, we can move on to the next step here, which is the model testing. Once the model is finished training, you can assess the model's performance using the appropriate performance metric. In this step, you will test the model on the samples reserved for testing. The model will predict the target variable, and these predictions will be compared on the actual values of the target variable in the testing portion. So before talking about the performance metrics that you can use, let's see what the predictions look like. So to be able to make predictions, you're going to need to use the prediction widget right here. This one. Still loading for a bit. And it's going to need the testing portion as an input as well. So what are you gonna test the model on? So you don't want the training portion to be used as the testing set as well, because this is what it's trained on. It's of course going to have a good performance for this one. You want to test. Let's use an example of a regression prediction for this one. So I'm going to import another data set right here. Actually, the same data set, but change for regression. So this data set right here is just the same except for this column right here. This column, instead of changing this into a qualitative value, I just kept this as quantitative. I just kept this as numeric. So let's say that will be my target variable. So let's redo the steps that we did a while ago. So the first thing that you need to do again is to select the the columns. You need to select the appropriate target. Let me properly import first. Forgot to press OK. There you go. So I want the target to be this one. So right now, this target is now a quantitative value. It's now numerical. And I'm going to keep all features again. And then after this, I'm going to split this into training and testing portions using the data sampler. So I'm going to keep this 90% still, and then sample the data to split it properly, and then create two portions. So this one would be the training. Okay, so for example, if you want to predict whether or not this specific trip will be late, given that the transport type is metro, that the origin station is 49, that the destination is 32, and that it's raining, and then these are the weather conditions, and the fact that there's no event and it's not a peak hour, we can try to predict whether or not this trip will be late. So we can use the predictions widget right here, and we can give it a model. So we can connect this model right here, the Legion model, or you can, instead of using this logistic regression that you just trained right here, you can also load the model that you just saved. And that's how you can reuse the model. You can reuse it in a different workspace, for example. So you can just use the load model widget, this one, and double click it and make sure you just load the correct file name that you saved, and then use this model as the predictor for this one. And once you do that, you end up with this prediction. So for this example right here, you have given the following sample, the following station and weather characteristics. It made the prediction that that trip will not be delayed. And that's basically how you create predictive insights. So that's it. Thanks, everyone.